All right, so on this lesson, we're going to be talking a lot about the zeros of polynomial functions. And we have already talked about the zeros of polynomial functions, but now we're going to talk about all the real zeros, and we're going to talk about all the imaginary zeros also. So that takes us to the fundamental theorem of algebra. So this is what algebra is all about. Like, algebra was written for finding zeros of polynomials. I wrote what it is, like, officially. So if f of x is a polynomial of degree n, where n is greater than 0, then f has at least one 0 in the complex number system, which includes all real and imaginary numbers. So no matter what the polynomial function is, as long as it has a degree of greater than 0, which means 1 or more, then it is going to have at least one 0. And then the linear factorization theorem takes that one step further, where it says that f of x has precisely n number of factors. So the number of factors matches up exactly, number of linear factors matches up exactly with the degree. And so if we're talking about zeros, linear factor will always give you 1 0. So this also means that f of x has precisely n zeros when taking into account multiplicity. All right, so the number of zeros matches exactly with the degree, as long as you are taking into account the imaginary and the real, and if there's a repeated 0, you count that many times. All right, now we're going to use something called the rational zero test to find possible rational zeros. So basically, we're going to say that a rational zero is going to be in the form of p over q, where p is a factor of the constant term, which is going to be a sub 0, and q is a factor of the leading coefficient, right? So what we're going to do is use this rational zero test to make a list of the possible rational zeros. And a rational number is a number that can be written as an integer over an integer. So what we do is we have all of the factors of the constant listed over all of the factors of the leading coefficient. All right. So let's look at example 1a. We want to just list the possible rational zeros. So what we do is we start off and we just list the numbers that represent p, which are factors of the constant, which is negative 15. All right. So all the integers that divide evenly into negative 15 is going to be positive and negative 1, positive and negative 3, positive and negative 5, and positive and negative 15. All right, and then Q represents the factors of the leading coefficient, which in this case is 2. So that's positive and negative 1 and positive and negative 2. All right, so we're not done. We haven't made our list yet. We've just made what we need to make our list. So the possible rational zeros are going to be all the p's over all the q's. All right, so I'll start off and I'll put everything in my p list over 1. So when I put them over 1, I get positive. I get that list, basically, the blue list. All right, then I'm going to take everything in my p list and put it over 2. That's my list of possible rational zeros. So if there was a rational zero, which is a rational number that gives me 0 when I plug it in for x, it's going to come from that list. Okay, let's look at B. So let's start with P, which is the factors of the constant. And in this case, our constant is 24. There are a lot of factors of 24. Okay, that should be all of them. All right, and then we'll have our Q list, which are the factors of the leading coefficient, which is 1. Those are all positive and negative 1. Now, whenever your Q list is only positive and negative 1, the possible rational zeros, or the P's over the Q's, just end up being your list you wrote for P. So I'm not going to rewrite it. I'm just going to put a box around it. As you put all those over 1, or all those over negative 1, you're going to get the same exact list. All right, so that's just a tool to get us started for finding the actual zeros. So here are the steps. So to find the zeros of a polynomial function when you're not given any zeros and you're not given any factors. Now, when we did this on our last test, you were given some factors that you verified, and then you found the remaining factors and zeros. Here, we're given nothing but the function, and we have to do it all from scratch. So the first thing we'll do is make a list of the possible rational zeros. Right, then we're going to test those numbers from the list using synthetic division to determine if they're actual zeros. So if they are an actual zero, you should get 0 as your remainder, and then you can use that as one of your answers. And then step 3, once you find 1 or 2, so if it's a cubic function, you only have to find 1 0. If it's a quartic, you're going to need to find 2 using this testing. And then you can solve the remaining polynomial function, or what's left, to find the rest of the zeros. Now, a quick note to test to see if 1 is a 0, all you have to do is add up the coefficients. If you add, the coefficients and the constant. So if you add those and you get 0, then 1 is a 0, and you can use it in your synthetic division, and you don't have to guess. You know for sure that it's a 0. All right, so let's start working on these problems. So on example 2, the first step is to list the possible rational zeros. So that's going to be part A, that's where we do the P's and the Q's. Now, I noticed that our leading coefficient is 1, so the possible rational zeros are just going to be the factors of the constant, which is positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. All right, for B, we are going to find, since it's cubic, we need to find 1 actual 0. Now, if I want to test 1, I can just add the coefficients and the constant and see if I get 0, and I don't. I get negative 12. So that's not, 1 is not going to be a 0, so we don't need to worry about it. So then it's just a guessing game. It's like, who can guess what 0 is going to work? So we'll just pick numbers out of the list and see if they're actual zeros. So you can start with negative 1, or you can start with 2, or wherever. It's really just guessing. So I'm just going to start with 2 and see what happens. Now I did fill in a 0 for x squared because it was skipped. Alright, so I get a remainder of -12, so that is a big no. It is not one of your zeros, so 2 did not work. So then you just go to another one. You could go to -2, or you could go to -1, or you could go to 3. I'm just going to go to 3 because I'm just trying numbers. Yay! So as soon as you get that, have a remainder 0, then 3 is a 0, and definitely you get excited because you're almost there. You've kind of done the hardest part of it, is figuring that out. And then we take our numbers under here and we write a new polynomial. Since the synthetic division worked one time, that means that I went from a cubic to a quadratic. All right, so the B part says to find all the zeros. So finding all the zeros means taking what's left over and solving it, setting it equal to 0 and solving it for x. So I know that my zeros are going to be -2 and, sorry, that should have been a plus, -1 and then 3, because that's the 0 I found using synthetic division. Now, this was a cubic function. It should have 3 zeros, and it does have 3 zeros. All right, and then the C part tells us to write the polynomial as a product of linear factors. So that would mean that f of x equals, and then you would write the factors that would give you those zeros. That is it. So that's A, B, and C. Okay, so it can be somewhat tedious depending on how many possible zeros there are and how good of a guesser you are. All right, for A. So this is another one where the leading coefficient is 1. So my possible rational zeros are just going to be the factors of the constant, which is 10. So there they are. For the B part, first I would check 1. To check 1, I'm going to add the coefficients and the constant to see if I get 0. But when I do, that's -5, -7, I get -6, so no, that doesn't work. 1 is definitely not going to be a 0. So then I try something else. I'm going to try 2. And 2 does work. All right, so don't get too frustrated if it takes you longer. Like, I've already had these problems worked out, so I know what's going to work. It might take you guys a little bit longer. So to find the remaining zeros, what you're going to do is take that polynomial function. Since it's cubic, I only had to do synthetic division once and get 0 once for the remainder. And then I can write it as a quadratic, where I can solve this by subtracting 5 and then taking the square root. Now, don't forget that when you solve an equation by taking the square root, you do the positive and negative square root. And because there's a negative under the square root, you do have to pull out an I. So all of your zeros are going to be positive I square root of 5, negative I square root of 5, and then the 2 that we found from synthetic division. Right? And then the C part, we want to write the function as a product of linear factors. And that's it. Now, linear factors, the x is not going to have a power, so Those are the linear factors. All right, so that's 3 zeros for cubic, so we are right. Should be right. We have the right number anyway. All right, so on this last one, finding the possible rational zeros is a little bit of some work. So we're going to start with P, which are the factors of 24. There's a lot. All right. Oh, sorry. And then we also want to do Q, which are the factors of 9. There's several there also. So then we're ready for the possible rational zeros, which is going to be all your P's over 1, all your P's over 3, all your P's over 9. So all your P's over 1 is just that original P list. All right, and then we'll put each one of those over 3. When we put 3 over 3, it's 1, which is already in the list. So we move to 4. When we put 6 over 3, it's 2, which is already in the list. When we put 12 over 3, that's 4, which is already in the list. And then when I put 24 over 3, that is 8, which is already in the list. So we're done with 3, and we'll go to 9. When I put 3 over 9, that's 1/3, which is already in the list. When I put 6 over 9, it's 2/3, which is already in the list. 12 over 9, it's 4/3, which is in the list. And then 24 over 9 is 8/3, which is in the list. So this is it. Those are our possible rational zeros. It's a lot of them. Okay, so we're ready to start trying zeros. So to try 1, I would add 9 minus 9 minus 58 plus 4 plus 24. That does not give you 0, so 1 is not a 0. So we're done with 1. So we could try 2, 3, we could try -2, -3, 4. I wouldn't go up to the 24. I would start kind of in the smaller. And I already know what works, so I am just going to do it. In class, we would see who was the best guesser. Okay, so 3 works. We get a remainder of 0. Now this is a quartic function, which means I need to find another 0 through synthetic division, and I'm going to just use these numbers. Alright, so we're not going to use 3 again. It could possibly have a multiplicity of 2 and be a 0 again, but more than likely we're going to have to try a different one. So 2 works. So that's 2 out of the 4 zeros we already know, which is good. Alright, and then that leaves us with 9x squared minus 4 equals 0 that we can solve by adding the 4, dividing by 9, and then taking the square root, positive and negative. Now don't forget, when you take the square root of a fraction, you're just taking the square root of the numerator, and you're taking the square root of the denominator. So that makes our zeros 2/3, -2/3, and then the 2 we found by synthetic division and getting a remainder of 0, which is 3, and -2. Alright, So then the C part, where we write our linear factors, try to think about what factor is going to give you a 0 of 2/3. So that's going to be 3x minus 2, 3x plus 2, x minus 3, x plus 2. I guess you technically could have written this as x minus 2/3 if you wanted to. That's not wrong. That's a linear factor, and that's true. And this other one could be x. That would be plus. This one would be x minus 2/3. Oh, sorry. I was right the first time. This one would be x plus 2/3. Okay, so your assignment is on this page. Just this box right here. It's 5 problems I want you to do. It's just doing all the things that we just did for that problem.